Hello and good morning, everyone, and welcome to It's Time to Build for Wear OS. I'm Ataul, a developer relations engineer on the Android team focusing on Wear. And this is Yuri. I'm a software engineer on the Wear team who's been working on tools and libraries to make building for Wear easier, faster, and more delightful. Today we're going to talk about Wear OS, what it's evolved from, and what it looks like today. We'll cover the different surfaces that are available to you on which to develop. And then we can share the kinds of experiences that we've learned work really well for this form factor. I'll then hand over to Yuri, who's going to introduce you to modern Wear architecture, Wear development the modern Android way, and then we'll cover how you can structure your code base to facilitate code sharing between your Wear, mobile, and other apps, and how this structure benefits your Wear app. We'll outline the few differences between navigation on mobile and Wear, because they're mostly the same. And finally, we'll take a look at some strategies that can help your app be more efficient, which is important in general, but especially important for this kind of device. So with a quick show of hands, how many people here today have owned or even just used an Android watch? Oh, awesome. So keep your hands up if you've used an Android watch in the last 4 years. Really cool. And in the last year? Wow. I was not expecting this, but great. So the reason it's interesting to ask is because it's changed so much over the last few years. So Android Wear was announced in March 2014, launching at Google I/O in June with devices like the Samsung Gear Live, the LG G Watch, and the Motorola Moto 360. It was running Android 4.4 under the hood, hence the name, with features like offline music playback if you had your phone nearby, GPS on the watch itself, and of course support for notifications on your wrist. And it was cool. Like, everyone was excited, and you had developers making unusual apps. One of my favorites was one where you could use your phone camera and preview the feed on your watch. So it was really handy if you're looking for something you dropped behind the couch until inevitably you dropped your phone as well. When the Android 5 update was made available at the end of 2014, the versioning system for Android Wear also changed. So instead of the Android OS version, we were beginning to treat Android Wear as its own thing. So we had this weird jump from Android Wear 4.4W to Android Wear 1.0. This update also added some new features, so like an official watch face API, heads-up notification, and always-on apps. Just over 2 years later, in 2017, we launched Android Wear 2. So this update added support for standalone apps, apps that work by themselves without the need for a companion app on the phone. We added a keyboard, handwriting recognition, and cellular support, meaning that messaging apps were suddenly viable just using a watch. And the next big change was in 2018, when Android Wear was rebranded to Wear OS, again resetting the version. Later that year, Wear OS 2.0 launched with feature updates focusing on glanceability and performance, so improving app launch times and battery life. And these were the sorts of relatively quiet but foundational improvements that were necessary to get us to where we are today, which is Wear OS 3. So the newest iteration of Wear OS was developed in partnership with Samsung. Wear OS 3 powers the Samsung Galaxy Watch 4 series, and later this year it will be available on the Pixel Watch, which was announced at Google I/O earlier this year, as well as becoming available as an update to select devices running Wear 2 at the moment. So nowadays, there's multiple surfaces available for developers building Wear apps. So unless you've been using an Android watch day-to-day, which it sounds like a lot of you have, awesome, it could be difficult or even overwhelming to understand where to start. So what does Wear OS look like today? What options do you have as app developers when it comes to designing and developing for a watch? In this section, we'll go over the different UI surfaces that are available, that the user sees, and for which you can build. The watch face is arguably the most important part of any watch. It has such a big role in defining the aesthetics for a timepiece, and it's what the user sees whenever they glance at their wrists. So it might be somewhat counterintuitive to hear me say, do not start here. So while watch faces are one of the most visible ways that users can express themselves, and creating a watch face can be a great way to showcase your brand, it doesn't make sense for every brand. Instead, consider starting by exposing data for complications. So a complication refers to any feature that's displayed on a watch face in addition to the time. For example, a step tracker, the outside temperature, or even an app shortcut. Complications are meant to be glanceable, which is one of the design principles behind Wear OS. This understanding that your watch is not the same as your phone, it's a lot smaller, it's not really meant for prolonged interactions, which is why it's so important that we reconsider how to support the user when designing for wear. The idea is that you can look at your wrist, and not only do you have the time, but you've also got immediate access to information that you've chosen, that you've decided is important, because it's the user who can choose which complications they'd like to display on their watch face. And this is nice, because for users, it's an additional functional aspect to the watch face. This watch face that you might have chosen for its aesthetics, that's going to be displayed 99% of the time, now also has this extra information without you having to interact with the device. There are a fixed set of computation data types, like icon, short text, or ranged value. So if you're writing a complication, there's no UI work involved. It's the watch face's responsibility to render them. Complication sources provide the data from your app, and the watch face can render it any way that makes sense. So this means that creating a complication requires relatively little investment. If you want to dip your toes into Wear OS development and have somewhat of a presence on the ecosystem, then this is the way you can do it. Creating a data source app without any activities, without any UI, and all you have to do is extend complication data source service to provide complication data when requested. Tiles are another UI surface on Wear OS that can present information from one app at a time. With a simple swipe from the watch face, you can find out the latest forecasts or start a workout where each subsequent swipe will take you and let you view the next tile. They're full-screen surfaces, providing easy access to the information and actions that users need in order to get things done. So they're designed for quick access to glanceable information, much like complications, and they ought to be predictable. So the user has to swipe to your app tile and trust that the layout of the information and the actions that you provide is going to be the same every time that they use it. And although tiles are full screen, they're not scrollable, so you have a fixed amount of space to work with. The reasoning here is, again, that these are meant for instant consumption of data. If you've got so much information that you feel like you need to scroll, using a tile is not the right surface. Another big difference between complications and tiles is that you provide the layout. So although the system is responsible for rendering the tile, you have to define the UI yourself. This means there's slightly more investment required than with a complication, but it makes sense, because in return, you're in control of what the user sees. And you've got a lot more scope in terms of what you're able to present, and you're not just limited to a set of data types. Last year, we released Jetpack tiles, so a library that makes it possible for third-party developers to build Wear OS tiles. And this year, we've been working on tile material components. This is built on top of Jetpack tiles, and the aim is to provide an out-of-the-box component experience to make it easier and faster to build tiles that conform to material guidelines. You can find guidance and ideas for tiles on developer.android.com. Look out for the Wear Tile Design Kit. I think it's a Figma file that's available for download. And each one of these tiles can be built using the elements and layouts from the Tiles Material Components library, which should be going to beta in the very near future. You can also check out the Wear OS samples repo on GitHub, which has the Wear Tiles Kotlin project, showcasing usage of the tile material components. And finally, we've got overlays. So overlays are what you might be more familiar with in terms of a traditional app experience. So while complications and tiles are quite similar, glanceable info and quick actions, overlays provide interactive, scrollable views, which allow users to complete tasks which are too complex for tiles and complications. Your overlay can be written with Jetpack Compose. There are a few differences, like using Wear-specific dependencies and a couple of Wear-specific components, but for the most part, it should feel very similar to what's available for mobile. And although the development experience is similar to mobile, it's important to remember that this is an experience that's designed to be consumed on the wrist. So we're looking still for task-based designs, organized around achieving the user's goal as quickly as possible. So where on a mobile app, you might have multiple nested levels of navigation, your overlay should remain relatively shallow. On mobile, it's common for apps to be started from the app drawer, jumping into the launcher activity. And while that's possible on Wear OS as well, you should consider that complications and tiles are equally important launch points, jumping directly into the correct screen for a given task. You can open your app's overlay from the app launcher, as we just talked about. So this opens the main activity, so exactly the same as on mobile. But while this is a common action on mobile, consider it an uncommon action for Wear. So for apps that are used frequently, it's much more likely that they'll be open from the other entry points that are more convenient, like from a notification. These are timely and contextual and should open the relevant screen in your app when they're tapped. Or a tile. So if a user's added your tile, it's very likely that they'll want to interact with your app. Tapping Start Here should open the correct screen in your app's overlay and immediately start the workout. Or a complication. So these are on the user's watch face, so they're front and center. Tapping on the steps complication should jump directly to the screen in your app's overlay that shows details about the user's step goals. And finally, we didn't really talk about this one, but there's also ongoing activity notifications, which can be used for long-running activities like a workout. So these are displayed at the bottom of the watch face, and tapping here lets the user return to the relevant screen in your overlay. Throughout the rest of this talk, keep these surfaces in mind and how they might be applicable to your app. We're about to share a few examples, and then Yuri will cover some technical considerations. So while he's doing so, you can be thinking about how these pieces fit together in your app. You're not going to be building all of this in one go, so think about which ones does it make sense to start with for your use cases, and how can you build it up over time in such a way that you can see the progress iteratively without a lot of front-loaded investment. Here we're going to take a quick look at a few common use cases for Wear. So we'll be orienting our designs around critical user journeys, or CUJs, small, specific, and simple tasks that make sense on a watch. These are experiences that we know that users are interested in, that we know work. So if they're similar to your own apps, this is the section for you. And if they're not similar to your apps, this is still the section for you, because we're going to be looking at how these surfaces that we just introduced fit together, and you'll be able to see examples in the context of a real app. So the first thing you should consider is whether your mobile app can support Wear OS without building a Wear app. So notifications in general should work out of the box. If your app supports messaging, then make sure to use the messaging style in Notification Compact to enable direct replies from the watch. And for media apps, Wear OS supports remote control via System UI as long as your mobile app is using media sessions. So these are super small actions that you can take today that Wear OS users will come to expect from your apps. So make sure you do these first. Messaging apps solve some of the most important critical user journeys that exist on smartwatches today. So being able to message independently of your mobile device is really handy when you want to go out without your phone or your phone battery just dies. Wear OS supports standalone messaging apps, and here we can see an overlay with two screens, a conversation list, and a conversation. Be sure to consider launch points for these messaging apps. So message notifications should open the relevant conversation immediately, and you can leverage tiles to provide handy shortcuts to favorite contacts or even to start a new conversation. And these are all nicer experiences for watches when you compare it to going to the app launcher, scrolling to find the app, and then scrolling to find the right conversation. They're small things, but they make a big difference. So the more convenient you make it for your users, the more likely they are to use the app. Media playing apps have two critical user journeys which stood out from our research. So users want to be able to listen to songs without their phone, and users want to be able to download songs so that they can listen without their phone. So being able to sync a playlist of songs or podcasts for offline playback means that you can go out for a walk or a run without your mobile device. And here we're showing two screens which should be fairly common across the majority of our media playing apps, a player screen and a library. So one thing that's important to note is that you should avoid media playback from the device speaker. So a lot of the Wear devices that are coming out now do have speakers. They aren't designed for music playback. It will sound bad, and it could degrade the performance of the device. And again, consider the other surfaces that are available. For media apps, showing recently played or recommended playlists on a tile could be useful, and these should jump to the relevant section or the relevant screen immediately. And in this example, tapping the Browse chip opens the overlay at the library screen, which shows all of the downloads on the device. And don't worry about going overboard trying to think of different tiles. Although users can add multiple tiles per app, the most important thing is that the most common critical user journeys are supported. And health and fitness is the last example we'll cover today before I hand over to Yuri. So there's two main use cases for health and fitness on a smartwatch. One is passive tracking, like steps, heart rate, or sleep quality. This is something a user wants happening in the background without having to take explicit action, because it could all be happening all day in the case of steps, or spanning multiple days, like sleep tracking. And number two is active tracking, tracking a workout explicitly. So you're going out for a run, or you want to track your yoga session. Here, users are interested in session-based summaries. So you can see your stats after you finish, but also live stats during the workout too. So being able to see your pace, for example, when you're running, or your heart rate when you're cycling. Prior to Wear OS 3, each app would be responsible for querying essentially raw values from the sensor manager or fused location provider. On Wear 3, we now have a new API called Health Services, which lets us pull battery-efficient sensor data from the watch, allowing us to track high-frequency metrics with less battery drain. Health and fitness tracking requires sensors to be on it all the time at high frequency to measure exercises, daily activity, and sleep, ideally across multiple days. So things like GPS, heart rate, etc. So these sensors and algorithms used to be managed by each app in the main application processor. And this is the same processor that was responsible for output, powering the screen, so any haptics in the speaker. So it's relatively high-powered. So when sensors provided data, the main application processor had to wake up to process it, and this had a big impact on battery life. Health Services enables all integrated apps to take advantage of modern smartwatch architecture. So it manages sensor data on behalf of apps, and now the data collection and processing of these sensors can be offloaded to a smaller, low-power coprocessor, the MCU. This allows the application processor to be suspended for extended periods of time, including while recording an exercise, and that means that health services can consume much less power than alternative APIs while still delivering high-frequency data. And this, in turn, results in longer battery life and a better user experience. Health and fitness apps are also great candidates for tiles and complication surfaces. So being able to start a workout is a perfect use case for a tile. I love being able to swipe once from my watch face when I'm tracking an active workout like a bike ride or a run. And here you've got multiple options based on how users interact with your app. Lots of apps have training programs, so instead of displaying a static entry point into a workout, you could offer a little more information or personalization and offer the ability to start the next session in the user's training plan. And finally, complications are excellent for displaying passive metrics like steps or last night's sleep quality. Users can see it at a glance and click through if they want to see more details. So hopefully now you've got some idea of how these different surfaces can form one coherent app experience. I'm going to hand over to Yuri now, and he'll be talking about modern Wear architecture.
So modern Wear OS architecture looks a lot like modern Android architecture. It leads to a familiarity of libraries, maybe retrofit, room, Android X, navigation, compose. It ensures a familiarity of concepts. Your colleagues know what you mean by view model, repository, navigation routes. It saves you from watching from the sidelines as your mobile colleagues adopt new mobile-only approaches or libraries while you stick with the older tech. And while there are some replacements, such as Wear Material and Wear Navigation, these Wear OS-specific libraries are faithful to the mobile equivalents. So very little of what I'm going to talk about contradicts the latest Google samples that demonstrate good app architecture. You've just heard about Now in modern Android, and most of this applies to Wear OS development as well. So check out the Now in Android project. It doesn't feature a Wear module at the moment, but that's my point. The structure that it employs for an Android app is exactly what you should hope for when you go to add a Wear module to your code base. Learn from these projects adopt good processes for maintainable software development, such as modern Android app architecture, layering things like the UI, data, and domain layers, and you'll be well placed for collaborative Wear development with your mobile colleagues. Because I'm not going to cover the aspects of Android and Wear development that mostly overlap, be sure to catch these talks. You're too late for Is My Application Taking Up Too Much Power? But later today, check out Modern Testing on Android, which covers fast screenshot testing and how to test the different layers of your app. Tomorrow, deep dive into modern Android performance and implementing modern Android architecture, which will also look at the Now in Android project. And on Friday, inspect and improve app performance. The lessons for mobile projects are generally the same as for Wear projects. If you look at the Now in Android project, you'll see the modules split out into core, feature, and app. Follow the same patterns for your Wear app modules and consider what is shared between Wear and mobile. It provides the opportunity to write functionality focused on your mobile app first and reuse it on Wear, dramatically shortening your development effort and avoiding falling behind as changes are made to the mobile app. You certainly shouldn't ship your mobile app's feature set on Wear. But when you do choose to bring those critical new features to Wear, you should consider how you can reuse the work of those new mobile features. Even on Wear alone, this also enables a common approach below the UI layer that doesn't need to change as you migrate an individual screen from Wear views to Wear Compose. Your repository classes don't need to change, even possibly view models, navigation routes, and deep links. So visit developer.android.com/wear for our latest guide on UX and architecture. The docs here are extensive and cover technical but also design guidance, making sure you make the best experience for your users. Right, so Compose for Wear OS offers navigation composables, which are intentionally very similar between Wear OS and mobile, so you can carry over all your Compose knowledge. At the same time, we have Wear OS versions of the navigation components to ensure that apps feel great on the watch, such as a swipe to dismiss gesture out of the box. Using these navigation components like swipe dismissible navhost within a single activity will give the best experience for users. The destinations you define can be Wear composables, or an existing Wear view you haven't migrated yet, or even a separate activity if required. Next, for navigation, Wear OS apps should be shallow, so avoid deeper than 2 levels, and linear, so show most content and navigation in line. Focus on the 1 or 2 critical user journeys that your users will expect to be available from their wrist. Pick the ones that make sense, tailored to users' current location or timely, rather than browsing or searching through infinite items. Leave the more interactive journeys to the mobile. Don't launch the user into a menu, making them think about which screen to navigate to. Focus on quick, sharp interactions, and avoid delays or upfront decisions such as menus or loading screens. As Ataul mentioned, think about the interaction style for these CUJs, and whether they start from a complication or a tile, and use those as separate launches for your app, getting the user straight into where they want to be with a single click. As well as app launches, all of tiles, complications, notifications, and ongoing activities allow the user to control how they use and interact with your app. These surfaces all show the user your app content, from a quick glance at the watch face complication, maybe seeing how long until the next bus, to swiping it to a tile with their daily commute. Make sure you refresh these ahead of time to make sure the user sees correct results. We'll come to this more later. And from either one, a simple click should navigate the user directly into the specific part of your app, seeing consistent results. The bus arrival time shouldn't jump at this point, suddenly showing a delayed bus. They should be seeing the fresh results before they click. So don't start with the assumption that the user needs to launch into your app. The tile or the complication may be enough. Now, there are some common UX patterns that we require developers to follow on Wear OS, and the scaffold provides a layout structure to help you line up components. Scaffold gives pre-built templates for Wear-specific layouts, which include such top-level components like a time text, vignette, and position indicator, and it already handles both round and square devices, which makes things even easier. The latest Wear material guidelines require an app to display time at the top of the screen within the app overlay, apart from dialogues. So this composable uses curved text under the hood and gives you a way to show the time without any extra work. Vignette. A vignette adds a blur effect to the top and bottom edges of the screen when it's capable of scrolling. The position indicator, also known as a scrolling indicator, which is aimed to show the current progress on the right side of the screen based on the state of the object you pass in. Why do we put this in scaffold? Well, due to the curvature of the screen, the position indicator needs to be centered on the watch. Easy to get wrong and cut off if it's not in the scaffold. The page indicator helps you implement pagination. It provides a great form factor specific visual indication. And finally, we have your content. This is similar to mobile. Your app content will live in individual navigation destinations, changing as the user navigates around your app. The app theme and scaffold will remain at the top level of your single activity architecture app, and this is also where you'd place any components like a snack bar. To help with this, and to implement the UX guidance, we've released Horologist. Horologist is a group of libraries from Google that aims to supplement Wear OS developers with features that are commonly required by developers, but not yet available. Think Accompanist, but for Wear OS generally instead of Mobile Compose. These libraries are open source, they're on GitHub, and while it's developed mainly by my team, contributions are welcome. Here are some of the features. So Compose for Wear OS has everything you need to build a Wear OS app, but there are a ton of subtle complexities here. The scaffold, as we said, should be above the nav host. A single component that reflects the state of the current navigation destination. The time text should scroll out of the way when the content in the column scrolls up to the top. The position indicator should stay in sync with the list on screen. The screen should scroll with bezel or rotating crown. And some screens may not want time text or position indicator. Sure, you can write this yourself, but you'll end up writing this component. So use Horologist Wear Nav Scaffold. How about date and time pickers? On mobile, you probably have a choice of 10 or 20 libraries for this. These are straight from Google's Figma designs, implemented in line with material guidance. They are high quality and should be your go-to for date and time entry on Wear. But these components also show a pattern for reusable UI components with the implementation shared between them. Software reuse is vastly more achievable with Compose. Something more specific now. Looking at media. Again, high-quality components guided by the Google UX team, themable but also completely customizable. Change the way the media is displayed, swap out the controls for music, podcast, or live streaming controls, add a background, media artwork, all while working within a careful screen layout. We will be adding animated effects for buttons and progress changes, and moving on to secondary screens such as library and playlists. These are all extracted from working applications, so we're providing exactly the same components that we've been collaborating on with media partners. But what are some of the patterns we can learn from Horologist if we want to reuse functionality? Firstly, split your composables into stateful and stateless components. And once you have these stateless components, get familiar with the previews in Android Studio. Use them to show every state of your application and also show variations such as device shapes, font sizes, languages, problematic content, error states. And once you have these previews, use a screenshot approach to automate UI regression tests in your CI builds. Make your composables themable, even if you only have a single theme. Use the semantic material colors such as primary, secondary, on background, instead of hard-coded constants. These let you update your UI in a single place when you have a design refresh. Now, on the mobile, you'll often want to load data as the user navigates to a particular page, such as the news feed. The mobile will have Wi-Fi or plentiful cellular data. Let's call this an online-first experience. While this will be typical also on modern Wear OS devices, it isn't a safe assumption to make. When your complication or tile service receives a request, this is not the time to fire off a network request or get a fresh GPS location. You have a strict time window to fulfill the request, and the network may not be available at this time. Instead, you should be responding immediately to requests served from recently cached data. This ensures your user sees consistent results when they click from a tile or complication into your app, and also avoids duplicating the same app logic and network requests. You should assume an offline-first approach, avoiding showing different data, slow loading screens, or network error when the user opens your app. But what does this look like? Well, firstly, be intentional about network usage. Change your view model to read the content out of the database. With Room, this can be a subscription to the database, returning a flow. Use subtle animations while updating the content already on screen to draw the user's attention to important changes, say a bus cancellation. Use a work manager job to update the database, automatically triggering a new result from your Room query and refreshing the UI. If the results look stale, let the user know and show some status while you're fetching fresh results, and use the user's activity to help you decide when to use the network. Work Manager really is the key to this. Use Work Manager to schedule your data refresh jobs. Work Manager can let you run periodic jobs when the conditions are right, either deferrable until a network is available, or long-running with a foreground notification. But you can also run one-off urgent jobs related to user activities. Being intentional about network use means making decisions like deferring loading artwork icons when only LTE is available, or maybe even no network. Doing this as the user scrolls through a playlist with each artwork shown isn't a great experience. Instead, prefetch content you expect the users to see, including images, in a background job when the user is charging their watch at home on fast Wi-Fi. Make sure you cache images and are using Wear-optimized image sizes. If the focus of your Wear app is on one or two user journeys, critical to the user, then you can make educated decisions to load the data to support those, your home screen, and the tiles and complications at this point. When the user opens your tile, you'll get a call back. So consider what else you should do at this point before the user clicks to open your app. And now, back to Ataul for a recap.
So today we covered a lot of content at a very high level. We talked about the history of Wear OS over the last 8 years and gave an overview of what this looks like today. So with watch faces, complications, tiles, and overlays. Yuri showed us that building for Wear doesn't mean starting from scratch. You can reuse a lot of code from your mobile projects, as well as the same architectural concepts. And you can write your overlay UI with Jetpack Compose. We've invested a lot over the last 8 years. And especially in the last 2 to 3 years, it's ramped up. And I think our having partnered with Samsung to develop Wear OS 3 demonstrates that we believe in this platform and form factor, and that wearables are worth investing in. But what should you do next? So the first thing I'd recommend is coming to talk to us. Yuri and I are going to be available at the Android booth today at 1 p.m. and also tomorrow at 10 a.m. But if you see us around, feel free to stop us for a chat. If you're watching from home or after the conference, you can reach us both on Twitter or on the Kotlin Lang Slack. For those looking to dip their toes into Wear, I'd check out 2 of the code labs that we have. So one is on tiles and the other is for Jetpack Compose. And finally, please do give us feedback. So whether that's on documentation that's missing or could be improved, or on APIs that don't fulfill your needs, let us know, because it is taken into account. If you have any questions, I think there is a little bit of time for that. But otherwise, thanks for coming today and thanks for listening.